Welcome to Fluid Coding and AI. 3 coding agents can sit inside one Xcode project, but sharing an IDE is not the same as sharing judgment. The real test is whether Codex, Claude, and an open protocol agent can leave behind fixes that are equally correct, visible, and reviewable. Start with a bug that only appears when context collides. A shopping cart row looks fine in English at the default text size. Switch to German, use an accessibility text size, and squeeze the layout onto a small or landscape device. Now the long product title clips, the remove control gets cramped, and VoiceOver announces a generic English action. That is one customer bug, not 4 disconnected chores. The row is unusable in a supported localization and accessibility configuration, even though the happy path looked perfectly innocent. The acceptance test has to exist before an agent touches the code. It launches a deterministic long product fixture in German, checks that the remove button is hittable, verifies a contextual German accessibility label, and runs Xcode's audit for clipped text, dynamic type, hit regions, and element descriptions. Hash the test and fixture before every run. If an agent skips the audit, relaxes the wording, or teaches the test to ignore the bug, that run fails automatically. Passing by moving the goalposts is still failing, just with extra paperwork. Now make Xcode the control group. Every agent starts from the same clean commit, Xcode beta build, SDK, simulator runtime, device, orientation, locale, text size, permissions, tools, and prompt. Record the exact agent package, model, effort setting, account tier, and transport. Use isolated worktrees so no agent inherits another agent's patch or conversation. Keep build caches equally warm or equally cold, and set the same time or tool call limit in advance. Without those controls, you are comparing 3 moving targets and calling the blur a benchmark. Xcode contributes far more than a text editor. It can ground an agent in project source, build settings, open files, and the active selection. It can search current Apple documentation, build the target, return compiler diagnostics, run tests, and render SwiftUI previews with appearance, orientation, and type size variants. Xcode 27 also adds string catalog tools and Apple-authored specialists for localization and accessibility. Those capabilities belong to the IDE and Apple toolchain. A model chooses whether to use them well, but it should not get credit for inventing the simulator or discovering that compilers have opinions. Here is where my expectation changed. The Open Agent Protocol story is actually 2 protocols working together. ACP connects Xcode, the client, to an agent session. MCP exposes Xcode's tools and context to that agent. Gemini's documented ACP mode shows the composition directly. Xcode controls the session, advertises IDE capabilities through an MCP server, and mediates file system access. So the interesting question is no longer whether every model sees the same chat box. It is this: if the agents receive comparable tools, do their fixes and evidence actually converge? Runtime state is another Xcode contribution. Device Hub can expose a live simulator or device, mirror conditions such as orientation and text size, manage app data, and make the reproduced state visible to the developer. Agent tools can boot a simulator, install and launch the app, synthesize touches, and capture screenshots. That matters because a preview is a fast receipt, not proof. It cannot establish real hit testing, VoiceOver order, or the application's actual data path. The test result, simulator state, screenshot, and brief VoiceOver check need to agree. The agent stack contributes the judgment. Does it inspect the project before editing? Does it connect the fixed height, one-line title, long localized copy, dynamic type, and weak accessible name? Does it consult current SwiftUI guidance or guess from memory? Then watch the patch. A strong run preserves the test, follows the existing style, changes only presentation and localization code, and uses several validation tools. A weak run may compile while missing the customer bug, rewrite unrelated layers, or declare victory after one green check. The unit under test is the whole stack, model, harness, instructions, effort, tool policy. The clean comparison set is Codex, Claude Agent, and Gemini CLI through its documented ACP mode. Xcode's native Gemini integration is a safer fallback if the custom path is unstable, but label it honestly because that tests provider parity, not the same external protocol path. Give every agent one prompt, fix the failing cart row test without modifying tests, preserve project style, make the smallest reasonable production change, and verify with builds, previews, tests, and the simulator. Do not prescribe any layout or view that fits. The outcome matters more than forcing identical code. Score the evidence, not the confidence of the final paragraph. A clean build is 10 points. The original test passing unchanged is 20. The regression suite is 10. Required preview and runtime states are 15. Accessibility is 15. Localization structure is 15. Patch minimality is 10, and an honest evidence summary is 5. Keep speed, tool calls, and cost separate, because a fast, fragile patch should not outrank a slower, correct one by arithmetic. Save the diff, transcript, plan, test result bundle, preview, simulator screenshot, versions, permissions, and failed attempts. The agent said it tested is not an artifact. Accessibility and localization are where shallow fixes usually unravel. A SwiftUI button can show only an icon while retaining a localized textual title for VoiceOver. String catalogs preserve context, and interpolated localized text can keep word order flexible across languages. A hard-coded English label cannot. The row must also grow or rearrange at accessibility sizes instead of clipping inside a fixed height. Even then, a passing automated audit is necessary, not conclusive. Apple still recommends assistive technology testing, and machine-generated German still needs native speaker review. Reviewability includes boundaries, not just patches. Xcode exposes plans, diffs, previews, tool calls, and agent activity, while its settings control allowed commands and can monitor file system access. Record which project data may reach each provider and every denied command. Xcode 27 is also beta software. Its release notes describe issues that can affect a comparison, including missing Apple skills for Codex without a workaround, stale ACP agents in the interface, inconsistent plan confirmation, device hub gaps for parallel test simulators, and simulator inspection trouble in Accessibility Inspector. Pre-flight the same tools for every agent and log. This is why public leaderboards cannot pick the winner in advance. Provider evaluations use different models, reasoning settings, harnesses, attempts, and tasks, and none of the cited headline suites test this SwiftUI workflow. There is a sharper warning, too. In July 2026, OpenAI reported that automated analysis flagged 27.4% of the public SWE Bench Pro tasks as broken, while human annotation identified 34.1%. The problems included strict tests and underspecified or misleading prompts. One frozen Xcode case is not a universal ranking either. A valid fix does not need one blessed code shape. Any layout can switch between horizontal and vertical containers as dynamic type changes. View that fits can select the first layout that fits. A careful adaptive stack may work too. The invariant is behavioral. The row grows or rearranges. The remove action stays hittable and contextual. The string catalog owns the wording. The original test and full sweep pass, and unrelated business logic stays untouched. Different patches can all be correct. Comparable work means comparable acceptance evidence and review quality, not identical. So, the defensible verdict is narrow. A CP can open a useful seat in Xcode, and MCP can put project-aware tools within reach, but neither protocol guarantees equal capability or equal judgment. Xcode supplies the shared context, validation machinery, runtime state, review surface, and permission boundaries. Each agent stack supplies the diagnosis, edits, tool sequence, recovery, and explanation. No local 3-agent run artifacts are available yet, so there is no honest model winner to announce. Until the patches, test bundles, screenshots, transcripts, and version records exist, a leaderboard would be marketing dressed as measurement. If you value coding agent comparisons with tests and receipts, like the video and subscribe to Fluid Coding in AI. More practical developer experiments are on the way.